This lecture is Chapter 2.4 through 2.5 and Chapter 2.7. And after this lecture, we'll be finished with Chapter 2. We're going to discuss how to create frequency distribution tables, how to construct histograms, and we're going to look at the shapes of distributions. Okay, this is a frequency distribution table. If you look at Chapter 2, Table 2.7, you'll see this table. When we create a frequency distribution table, we will also be adding a fifth column called relative frequency percentage. And so you notice that there are 5 columns. We have classes, frequency, class mark, class boundaries, and the fifth will be relative frequency percentage. The number of rows in this frequency distribution table indicates how many classes we have. So that's why this column is called classes. Here we have 1, 2, 3, 4, 5, 6, 7 classes. And the classes are broken down into individual ranges, and each range has an associated frequency, a class mark, which we'll talk about how to arrive at, class boundaries. Okay, so the definition is a frequency distribution table is a table in which a data set, which is a collection of numbers, has been divided into distinct groups called classes, along with the number of data values that fall into each class, called the frequency. So looking at the table here, our first class, 6 to 10, has a frequency of 29. That means there are 29 data values in this data set that have values between 6 and 10. Frequency distribution tables are useful in summarizing large data sets. Okay, so the meaning of study hours could be the number of hours a student studies per week or something like that. And if you have a collection of students in your sample and you survey these students, you may find that 29 of the sample students studied between 6 and 10 hours per week. And then you would survey the rest of your sample and see how the values fell given your sample values. Okay, so how do we build a frequency distribution table? Frequency distribution tables can be created with categorical data, but we're not going to be doing that. I'm going to be using numerical data only. So if you refer to the textbook on how to construct these tables, you can ignore the section on categorical data. Okay, you will have to be given a set of raw data values before constructing a frequency distribution table. Okay, so eventually those are going to go into a calculator list. The first step is to determine how many classes you are going to be creating. Now the classes then translate into the number of rows of the frequency distribution table. This is the number of groups the data will be divided into. Usually the number of classes will be given to you in a problem. If not, use 7. Okay, so when we read a problem that asks us to build a frequency distribution table, we'll have to take note of how many classes were asked. And if nothing is specified, use 7 as your default class number. Okay, so because we have 7 rows, in this frequency distribution table, the 7 rows translate to 7 different classes. So in another frequency distribution table, if there were 6 classes, then we would only have 6 rows. Okay, so we're going to do an example where we look at 50 students and we've recorded the amount of time the students need to complete the final examination. And here are the times. So these are to the nearest minute. And we have 50 values, starting with 50 and ending with 71. Okay, to construct a frequency distribution table using 7 classes, we have to start by putting the raw data into a list and sorting it. So go to your calculator. I'm going to open my calculator too and put the data in a list. Let's see. Okay, I just need to position this so that I could see the data values. Here we go. Okay, so we're going to press, let's recall from last time, we pressed Stat. And with Edit highlighted, we hit Enter. And our data from earlier, last lecture, are still in there, L1, L2. So if we don't intend on using L1, L2 in the future, which we're not going to, we can remove these data values. So using your arrows, left or right, go over to L1 and go up to the title of the table of the list L1. With L1 highlighted, press the clear key. Notice that all the data values that were down here are gone. Then press enter, and now all the data values here are gone. And then you could go over and do that to L2 because we won't be using L2 either. Okay, with an empty list, populate your empty list with the values from the handout. So we have okay, so I've put the 50 data values into a list, and we're going to sort the list now. So if you remember how to sort, you have to press the Stat key, go to number 2, Sort Ascending, and sort list 1. So I'll do that too. Stat, Sort Ascending, specify list 1, which is used by hitting the second key and then the 1. Close the parentheses, hit enter, and the list is sorted. Okay, so now you can go back and look at that list by pressing Stat, Enter, and L1 is now sorted. So you're going to make note of the smallest data value, which is 10, and then we're going to go to the very bottom of the list. We can press the up arrow twice. It'll bring us to the bottom. The largest data value is 120. So 10 is the smallest and 120 is the largest. Okay, so we have to use the following formula to find the class width. Now, the class width is not the same as the number of classes. The number of classes is simply how many rows or how many groups our data will be grouped into. The class width is basically the size of a class, and this is how we find it. We take our largest data value minus the smallest data value and divide by the number of classes, and then we go up to the next whole number. And we go up to the next whole number if we have a decimal, no matter what. And I have a couple of examples that show how we do this procedure. This is the only time in this class where we will not be following normal rounding rules. We're breaking the normal rounding rule and we're just going up to the next whole number. So let's look at what I'm talking about. In our example, the lowest value is 10, the highest is 120, and the number of classes is 7. So we plug these numbers into our formula. 120 minus 10 divided by 7. Now remember, if you choose to do this all in one step in the calculator, you have to wrap the numerator in parentheses. Okay, so you would do, and I could do this, I could show you. On your calculator, you've got, I'm going to quit this. Okay, if you wanted to do 120 minus 10 divided by 7, put the numerator in parentheses. The parentheses is right there. 120 minus 10, close the parentheses, then divide by 7. Okay, 15.7, etc. And then we go up to the next whole number, which makes it 16. That's going to be the rule, to always go up to the next whole number. Let me demonstrate what happens if you did not put parentheses in that calculation. 120 minus 10 divided by 7. Okay. Clearly, it's the wrong answer. Okay, that's not what we wanted to happen. We wanted to do the numerator first, which is why we wrapped it in parentheses, and then divide by 7. So our correct answer is 15.7. It's 0.7128571. We are just going to take that 15 and go up to the next whole number. So that's going to bring us to 16. So the class width for our example is 16. Now let me show you some other examples, because there is a homework assignment that you need to finish on this. This is homework number 2 on web work, and you may or may not get a number like 15.7 where you can follow normal rounding rules to go up to 16. And let me give you an example of what I'm talking about. Here are 3 examples of different frequency distribution table values, and if you were asked to find the class width in each of these, you'd see that they're a little bit different than what we just finished. Okay, suppose that the lowest data value is 89. The lowest data value is 35, the highest is 89, and the number of classes that we were asked to use is 6. To find the class width, we use the formula 89 minus 35 divided by 6. That is 54 over 6, which is exactly 9. But by the rule, we're going to go up to the next whole number. So your class width will then become 10. Okay, and now let's look at another example. The smallest data value is 10, the largest data value is 38. We were asked to use 5 classes, so let's calculate what the class width would be here. We take 38 minus 10 divided by 5, which is 28 over 5, which is 5.6. Go up to the next whole number. 5.6 up to the next whole number is 6. So the class width would be 6 in that example. And the last one, we have a smallest data value of 96 and the largest data value of 125 using 4 classes. So our formula is 125 minus 96 divided by 4, which becomes 29 over 4, which is 7.25. But then again, going up to the next whole number, we go up to the number 8, and so our class width is 8. Now this is the only time in this class where we're doing this kind of, this is called taking the ceiling of the number, because we're going up to the next whole number. We will not be using this kind of procedure for other things. Just keep it in mind just for this, just for creating frequency distribution tables.